We're going to talk about scientific notation today, which you probably know all about that, but I'm just going to burn through a little review and then we're going to build on it with engineering notation. So standard notation is basically writing, really big numbers or really small numbers with all the zeros. So 1,000,000, put all 6 zeros in there. Uh, I don't know what that is even. 7 with all the zeros in front of 0.0000007. Standard notation, got all the zeros. Scientific notation, its purpose is just a quicker and easier way of writing numbers with lots of zeros. Okay, so for purpose of review, that first number's got to be between 1 and 10, and the second number's got to be some sort of a power of 10. We'll also go through how to do this on your calculator. Your calculator is going to spit this out with this E in the middle of it, and that means 2.8 times 10 to the third. The E means times 10 to the third. It's a pretty common misconception for people to call that 2.8 to the third, but it is 2.8 times 10 to the third. So if I have the number 45879, all right. The decimal point is over here on the end, and we just move that baby over until the decimal point gets to a spot where it's a number between 1 and 10. So I'll put that decimal point right here between the 4 and 5, and basically we just count that up, that I moved it 4 spaces. So the answer is 4.59 if you want to round it, times 10 to the fourth, because I moved it 4 spaces. People also get hung up, oh, I moved it left, so should it be negative, or I moved it right, so it should be positive, or how's that work? And basically what I think about it is 4.59 is way smaller than 45,879. So if this first number right here, the 4.59 got smaller, then this number needs to be bigger so that, it compensates gets the same answer. It's that whole inverse proportion thing. Okay, here in our second example, the decimal point's here on the left. So I'm just going to move it over until I get to a spot where the number is going to be between 1 and 10. And so it's going to be 1.23, and I moved it 1, 2, 3 spaces. So this, again, is a deal where when I went from 0.00123 to 1.23, I made this number bigger. So that means this number has to get a little bit smaller in order to compensate for that number. That's just my way of thinking for, you don't have to get mixed up or memorize like, oh, I move it left, I move it right. I just want to make sure that the answer is the same size when we're all said and done. And, and so just kind of make sure that that happens. If one number gets bigger, the other number's got to get smaller. If this number got smaller, then that number's got to get bigger. Okay, so here's something a little bit new, but it's not really new. So, you guys are looking on the internet and your computers and how big they are and what size, memory it has and all that business. So if you had something with 30 megabytes, 30 meg, you come over here, you look up mega, and you see that mega means 1e6, which is really times 10 to the sixth. So 30 megabytes is 30 times 10 to the sixth, and which means 30,000 megabytes. All right. So as you look at this, this top part is the SI prefix, which stands for International Science Prefix. I had to Google that. And the engineering notation is the one that has, it's kind of like scientific notation, except for now our number is going to be between 1 and 1,000 instead of being between 1 and 10. And all of our exponents are going to be multiples of 3. And the reason for that is because that's where the commas go. So your last comma would go here at between these two zeros where it was 30. As you look up at 30 million, did I say thousand earlier? I meant million. You put your commas every three zeros, and your decimal point just goes where the last comma goes. Okay, in my next example, it says write 4 gigabytes in standard notation. So 4 gigabytes, come over here to the chart and follow over here and find giga. That's 1E9, which is 1 times 10 to the ninth. So we can just reveal that down. So that's going to be 4 times 10 to the ninth. Just look that up on the chart. And then take this number and move it over 9 spaces, basically filling in 9 zeros at the end. In our last example here, I have something like 12 milliamps. We just come over to the chart and find milli on the chart, which is right here. Oop, there it is. And you can see that that is 1e negative 3, which basically means 1, or 12 in this case, times 10 to the negative third. And then the negative third means you'd move your decimal point over 1, 2, 3 spaces, and you'd have 0.0012. So here we have it. We have our answer with an SI prefix, answer with engineering notation, which is very similar to scientific notation, only this number can be between 1 and 1,000, and this one's going to have to be a multiple of 3. And then standard notation is the one with all the zeros. I know I said the last one was going to be the last one, but I thought of another one. So we might have to take something like 1, 2, 3, so that'd be 123 million, and write it in engineering notation. So going the other way. So again, engineering notation means you move the decimal point to, so the first number is between 1 and 1,000. And then you just count up how many spaces I moved it, which was 6. So that's 123 times 10 to the 6th in scientific notation. And in engineering notation, it would use either the prefix mega, like if it was something electronic or scientific. But if you're reading it in the newspaper or something, you'd say probably million. If you come over here and look up 10 to the 6th, winds up being mega.